This video is all about different landforms created along the coastline. And before we look at the landforms themselves, we're going to think about waves because they play a really important role in creating these landforms. So landforms of erosion are created due to destructive waves. And these are our high, powerful, frequent waves. They have a weaker swash compared to their backwash. And that means that as that water is removed, that backwash goes back out to sea, they're removing sediment from the beach. In contrast, landforms of deposition are created by constructive waves, and these are our low, gentle waves where the swash moving up the beach is stronger than the backwash. So they're depositing material on the beach. They don't have the energy to take that material back out to sea. We're starting with landforms of erosion, and bays and headlands are our first landform. And these are created along coastlines where there are bands of harder and softer rock, different types of rock. And in these instances, the sea is eroding the softer rock more quickly. So those destructive waves eroding the softer rock more quickly. And this is creating bays where that softer rock has been eroded. And we often find beaches inside these bays. And either side of the bay, we have two headlands made of that harder, more resistant rock. So inside that bay, we have a much more sheltered environment where we have these beaches forming, usually quite calm conditions. Our next landforms of erosion are caves, arches, stacks and stumps. So these are formed along one of those headlands, that more resistant rock that's sticking out, and it's exposed from lots of angles to the sea because the softer rock either side of it has been eroded away. So this headland sticking out into the sea, and the destructive waves, the powerful waves that are bashing against the rocks, create cracks first of all. These generally are caused by hydraulic action where the water traps pockets of air within the rock, and as the water is removed, the air kind of blasts out and fragments and breaks off bits of rock, creating a crack. Over time, repeated hydraulic action and abrasion would grow this crack into a cave. The cave then becomes larger until finally it breaks through the back of the cave and creates an arch. The arch then eventually will be eroded, so the top of that arch essentially will collapse, and that leaves a stack, a sea stack, sticking out into the sea, and then eventually that sea stack will be eroded and weathered down until there is just a stump remaining. So before we move on to our landforms of deposition, we're going to just take a moment to look at a very important process that helps to create those landforms, and that's something called longshore drift. And longshore drift is essentially just the movement of sediment along the beach in a particular direction. And so here in the UK, that direction is generally to the east, and that's because our prevailing wind, or our most common wind, comes from the southwest. And so what happens is that wind is pushing sediment up the beach at the direction of the waves. So the wind is creating the waves. Waves are pushing the sediment up the beach in that direction. The backwash then comes back down at right angles, perpendicular to the sea. The waves continue to push that sediment along in that direction. On any given day, the wind could change direction, but the reason it's moving in this direction is because it's the most common wind. And so over time, what we're seeing is the sediment, so the sand, shingle, pebbles, moving along the beach here in the UK in an easterly direction. And this brings us to our first landform of deposition, which is a beach. So a beach is generally made of sand or pebbles, and the area that we call the beach is what we say is from the low water line, so essentially low tide, right up to the upper limit that waves could reach. So in a kind of storm scenario, how far do those waves reach up to the land? We find sandy beaches generally in sheltered bays. So thinking back to our bays and headlands, those areas where the headlands are sticking out either side, sheltering the bay from the wind. We tend to find more constructive, low energy waves here. And these beaches tend to be flat and wide because of those calm waves pushing that sand up the beach and creating a really wide beach. In contrast, we have pebble beaches, which tend to form along higher energy coastlines. And that's because destructive waves tend to remove the finer sand from the beach. So remember those destructive waves, the backwash is stronger than the swash. So the backwash is taking all that smaller sediment back out to sea and just leaving the larger pebbles that it doesn't necessarily have the energy to remove. So these pebble beaches tend to be very steep and narrow. So our final landform today is something called a spit. And a spit is essentially just an extension of the existing beach projecting out into the sea. So it's joined to the beach, it's joined to the mainland, and then it carries on being formed out. They're formed where the prevailing wind is blowing at an angle to the coastline. So what we tend to see is areas where there's a change of direction in the coastline or where a river meets the sea. Longshore drift continues in the same direction. Longshore drift is still moving that material along, and it continues to deposit material, but instead of it being along the coastline, this time it's coming out into the sea, as you can see in that diagram. Over time, with continued deposition, the spit continues to grow. The end of the spit is very often hooked because of the wind direction changing as we get further out to sea. And the waves can't generally get past a spit, so it's built up to a certain extent. It means that most normal waves won't be able to get past it. And so behind that spit, we start to see a salt marsh area, sheltered area, where we get silt deposited and mud flats or salt marshes are forming, which can be a really important habitat.